So good afternoon to all of the students available or present.
Good sir.
Good afternoon. So basically, in the last class, if you have seen or go through most probably everybody go through the notes that I have already shared with you in Google Classroom. So we have discussed about some basic fundamentals of structure analysis too, and its stability part as well as static and kinematic indeterminacy. How we need to find them out and what are the things need to be need to be focused on while calculating the static and kinematic indeterminacy and stability of the structure. So now to make those concepts to be more strong or more precise, always we need to perform some numerical problems. So after solving some problems, so you definitely get some confidence to solve a problem if it is asked in exam, might be. So in that case, you always have some confidence if you solve some problem related to the concept that we discussed. So, so we are start with the my voice is very low. Let me check it. Whether it's my voice is clear, audible or not, or I need to
Sir, it audio, but sir, very slow.
very low.
सर
Okay,
स्लो आ रहा है आवाज.
okay. Let me put it.
इंटेंसिटी लो है थोड़ा.
So now I think it's okay.
Yes.
Yes sir.
Okay. Sorry for disturbance because voice is not audible. So that's now I think it's okay.
Yes sir, now it's okay.
Now we have to solve some problem to make those concepts to be more precise or strong. That we were just discussing about. If you are not supposed solve some problem to particular concepts, it always be a conceptual thing, confusing thing actually. Because if you are not solving the problem, you might not get that confidence to solve the problem, which if might ask in exam in that case. So that's why I just bring this in this particular lecture. We are going to solve some very good problems. Those will help you to understand more accurately in a more precise manner of static and kinematic indeterminacy and stability of the structure. So one by one we will see and try to solve yourself before I will do it. So let me put the first problem in front of you. So you will first, let's see the frame which is showing in your figure. I think everybody can see the figure which is showing on the screen, which is having a hinge sport at the sport system. So need to calculate. Question is that there is a frame which is showing on your screen. If axial and shear deformation in the different members of the frame are assumed to be negligible, means we are not supposed to consider axial and shear deformation, the reduction in degree of kinematical indeterminacy would be equal to. So first of all, before going to the problem, what are the things we need to keep in mind? Read the question carefully and then you have to proceed for the calculation part. First thing, if the actual and shear deformation in different members of the frame has to be negligible. So before doing a negligibility thing, means before removing the actual and shear deformation in the frame, first of all, by considering all the negligibility items, means shear also consider and actual deformation you need to consider and calculate its overall degree of kinematic indeterminacy. Then according to the question, you have to follow that you need to remove or you have to negligible the things those are asked to do in the question, that is axial and shear deformation you have to remove. Then the thing that he asked that after removal all these values, axial or shear deformation, what is the degree of kinematic indeterminacy would be equal to after removal those. So first calculate total indeterminacy, then remove the axial and shear deformation, and then calculate the degree of kinematic remaining after that negligibility items we have here. So first we going to calculate, solve the problem by considering complete degree of freedom or kinematic indeterminacy of this structure. So let's see. So this is a frame again. So we need to consider, so how many joints do we have in this particular frame here? If you going to count these are the 1, 2, 3, 4, 5 and 6. There are 6 joints basically that you can see. For each and every particular these joints, as we consider those to be as a rigid joint, so always there is a three component of reaction will be there. One is in x direction, y direction, and one is rotational part. So there will be three reaction for each and every joint where we have rigid supports. Like in the support system, if you see here we have hinge support. Fine. So let's see for further. We have three here also on this point, and then we have three on this point and three at this point, and there are one rotation on the support system at this point, and the other is at this point. These are the total degree of freedom which is available in this frame without negligibility of axial and shear deformation. Fine. So let me count them. How many total degree of freedom without considering negligibility of other thing. So let me count them. 3 plus 3 6 plus 3 9 plus 3 12 plus 2 14. There are total 14 degree in the degree of freedom is available without considering or assumed to be negligibility of axial and shear deformation. So 3 plus 3 6 plus 6 12 and 2 14. Clear? Now, after removal, what are the things that will be removed after the axial and shear deformation? Axial means in upward direction, shear means sidewise. So how many that will be reduced? So there will be two will be going out. One is x direction, y direction. Similarly, for the other portion also, and there we have two. So there we generally consider in the same direction we consider to be x then this direction also x in this direction, because that deformation remain same on the both direction. That's why we can consider out of these two we can consider one. And axial deformation when removed means axially extension either can be a compression or extension can take place in this longitudinal frame, or you can call it as a column if you consider that. So that y component is also reduced for each and every portion, right? So how many reduction will take place, that we will count from here. Now these are the values or deformation or degree of freedom remaining after we assumed to axial and shear deformation to be negligible. In that case, one x will be out from here. Second, this will be not considered. This y will not consider, and this y will not consider. So how many remaining do we have? 1, 2, 3, 4, 5, 6, 7, 8. So total 8 is remaining. Then how many degree of indeterminacy is reduced after considering the negligibility of axial and shear deformation will be equal to total is 14. Remaining we are having 8 after doing negligibility concept, which is asked in the question. We are remaining with how many? There will be reduction will take place, or degree of indeterminacy will be equal to 6 only. So what are these? These are the total after removal or after negligibility of degree of freedom, axial and shear. So how many remaining or reduction will take place in degree of indeterminacy? That is total is 14 minus 8, that comes out to be 6. I hope everybody seen know or understand how to solve this problem. Anybody have any question, he or she can ask. Uh, so let me put it again. So question is the kinematic indeterminacy of plane truss shown in the figure is, the frame is in front of you. You can see this is a kind of a truss, plane truss, which is showing in your figure. And one the sport is hinge sport, other is roller sport. So you need to solve yourself and let me know the what should be its a kinematic indeterminacy, and then I will explain each and right. So guys, this problem is mentioned is on your screen. Is if you see the sports are, one sport is hinge sport, other is roller sport. So in this problem, question is asked about you have to find a kinematic indeterminacy of plane truss. So we have here one thing that we need to understand that we already discussed in the class also. First of all, count the number of joints. How many number of joints do I have in this frame? Fine. Plane truss frame, which is you can see here. And then forgot about the support system do we have. First count degree of freedom if there is no support system is there. So count the number of joints for each joint for plain truss. How many degree of freedom do we have if there is no support reaction? There is 2. Fine. For 2, for each joint may degree of freedom is 2 available. Count the number of joints, multiply by 2. You will get total degree of freedom of the structure without considering any support reaction. Fine. So let me count those. So total number of joints are 7. But what are these? 1, 2, 3, 4, 5, 6, and 7. These are the 7 joints which are showing in this frame only. So per joint, how many degree of freedom do I have? There is
Two.
these are the joints. Sorry, let me put it another way. So these are the joints. It is recollect. So number of degree of freedom per joint of a pin connected structures without any restriction is there. There is 2 degree of freedom available. So total degree of freedom, if you see how many, 7 into 2, that comes out to be 14. Now you have to count how many restrictions do I have. One is 2 is from hinge support, other is from roller support.
Roller.
3 degree restrictions are available. Fine. Now remaining degree of freedom is nothing but 14 minus 3. What are these? These are the 11 degree of freedom available. कौन सी होगी? Let me put in other way. So 1 is here, 2 here, 3, 3 to 5, 5 to 7, 7 to 9, and to 11. These are the degree of freedom which is available on these 7 joints. 1 at roller support, 2 at this point, 2 at this point. 4 plus 1 5, 5 plus 2 7, plus 2 9, plus 2 11. These are the 11 degree of freedom which is available in this plain truss structure. So I hope it is clear to everybody. Many people given the right answer, but some of the people even make a mistake. So let me repeat again. So guys, in this problem, there is not a such complicated thing is given. Just you need to count the number of joints first. Then at each joint for truss system, we have 2 degree of freedom if there is no restrictions. If a truss point is free into the space, it can move freely in 2 direction, x and y direction. That's why we consider there is a 2 degree of freedom for per joints. There are 7 joints, so total degree of freedom is 14. Now you have to count the number of restrictions are available, which is provided by the support reaction. So there are one is hinge support, other is roller. So hinge provide 2 reaction and roller will provide 1. So there will be total 3 number of restrictions which are going to be provided by the sports, and total we have 14 minus the restrictions. You will get the actual degree of freedom of these particular structures. So that's how you can solve this kind of problem if asked into the exam. So this is the other problem. So the degree of static and indeterminacy of rigid joint frame PQR 40 dash shown in the figure. So what should be the value that we need to check first? Let me so guys, again this problem I'm going to explain it. So those who are given right or wrong answer, they can verify their answers and what are the reason why the structure is unstable. Let me explain it. So if you see in this particular problem, which I just mentioned on your screen, is that in the general state of loading, if you see this structure is unstable. Why so? If you consider any force at PQ, or sorry, RQ, if you see in the RQ member, there is any horizontal force if you going to be applied, that structure become unstable. Why so? And in other case also, if upward force on QP also makes it unstable. Let me put another way. There is a reaction. What is the thing is mentioned is there? If I apply any horizontal force on R point, what will happen there? This hinge is also allow the rotation. This hinge also rotation, and cable is not supported any other load other than the axial force. Its cable is only taking care of axial forces. Either that can be at compression or tension, but mostly it's going to be carry the tension only. So they are not going to resist any horizontal component force which is coming into this cable. Might be that instead, but due to this force applied here, the body will rotate, or this cable is not going to resist any reaction forces here. So in that case also this system of support or diagram is going to be unstable. Second thing, If you put a vertical load here also, in that case also due to that vertical reaction might be reaction component will be there, but moment is going to be created and that moment is not going to be resisted by this whole complete structure. In that case, we call consider at this structure to be unstable. It's a node kind of problem that can be, you can call it as a determinate or indeterminate. This problem is considered to be unstable because the condition which is mentioned here, if you put horizontal force in the direction of RQ member, there is no restriction against to resist that force. Again, similarly, if you put a vertical load in that direction of RQ, same will this is also make this structure unstable because there is no resistance coming in front of these forces. Due to that moment, rotation capacity is not resisted by this cord, this member, and it will rotate in this direction as well as will move in vertical direction also. So that's how this structure can be unstable. So basically, guys, in this particular problem, you need to be visualize whether my structure is stable or unstable. So that first thing you need to be verified. Otherwise, many students maybe calculate the number of reactions or degree of freedom also, static indeterminacy in that case also. Sorry. So in that case also, if you getting value, maybe getting value negative, in that case also you can say my structure is unstable because maybe there is a partial constraint condition also, right? So that you have to verify. So that's the problem, which is very important. And one note which is mentioned that you need to verify and need to keep in your mind that I just explained to you because that RS, that is a cable which is only carried axial force and hence the force can be determined. That axial force can be determined. So in that case, these are the things that you need to verify before solving in case of indeterminacy and static and kinematic indeterminacy. First verify stability and then go for the determinacy. So students those solve in a different ways. So carefully, I'm going to solve this problem. So again, very basic and very simple problem. This one I suppose so. We need to find the static indeterminacy of two span continuous beam, as it, you can see. Even the things which is need to be confusing part here. That is, many people make a mistake. They are not going to consider two span, but that is a key point that we need to understand, but which is mentioned into the question. So that's the problem is solved in itself. But a big thing we need to verify here is that there are reactions we need to find out. First of all, how many spot reaction do we have in this problem? So we need to find static indeterminacy. So in the beam, as already explained in the previous classes, we do not have any internal indeterminacy. Only we are belonging with the static indeterminacy externally. Fine. Whatever the external indeterminacy coming, that is only the total indeterminacy of the beam case. So how many indeterminate reactions do I have in this problem? 1, 2, and 2. 4 and 2 are for internal hinge. So total indeterminate reactions, spot reaction coming is 6. For particular one member, how many equilibrium equations do I have? 3. There are two members, 3 into 2, 6. 6 minus 6, my structure is determinate, means it's a static indeterminacy coming out to be 0 only. So these are the spot reactions. So vertically, if you are going to consider only in the vertical case, in that case, these are the 3. Otherwise, there is a different way to solve this problem also. Fine. Make a free body diagram, represent the spot reactions, like 1 is here, 2 is here, 3 and 2 are from here, and 1 is horizontal also. So there are total 6 spot reaction which is going to be provided by the spot. Fine. 6 total unknown reactions, that if we are able to solve these unknown reactions by available equilibrium equations, in that case that structure considered to be determinate. Whatever the difference coming out of unknown forces minus available equilibrium equations, that considered to be your static indeterminacy. So there are 6 unknown forces. If you make a free body diagram, that means minus those available equilibrium equation. For particular one member, we have 3 equilibrium equations. There are 2. So 3 into 2, 6. 6 minus 6, 0. Now in this particular problem here, which I just mentioned, in other way you can read this one also. It's again a different way to solve this problem. Again, answer remains same. Either you can take that way that we understand in a better way, because we go through the same pattern in the theory also. For vertical loading, there will be only three reactions for this vertical loading only. So there are three reactions. We are not going to compensate the horizontal because there is no horizontal force. So we can nullify the horizontal support reactions as well. In that case also you can remove those. So if you are going to consider them, so that time you have to consider two horizontal reactions and two equilibrium equations additionally. So to compensate this vertical force, we have three component of reactions. So these are the three unknowns, and available equilibrium equations are three. In that case also, this structure coming out to be determined. Either of the way you can adopt, because we have to calculate the support reaction, which is deflection which comes into the support or coming into the beam due to this force only. So this force is going to be reaction is going to be provided by these vertical support only. The vertical support is three, available equations are three, so you can solve them by easily by using those three equilibrium equations. So
Yes,
either of the
sir.
way you can choose. Fine.
Yes, me, sir.
Yes.
सर वो जो रोलर सपोर्ट है वो सर बीम को डिवाइड करता है.
The roller support will not going to be divided. This internal hinge will divide. This is the support which is under the beam, not in between the beams. So
सर
under
इसमें
the beam
मेंबर
they are
देखिए
only
कितना
providing
होगा
the
सर.
support. This internal hinge will divide the beam.
सर इसमें मेंबर देखेंगे तो कितना लेंगे सर
There
मेंबर.
are two members, one and two. One member, because this is a member which is supported by two rollers. This is a one member which is supported by one hinge member, and they are connected by internal hinge. So there are two members. That's why this is a determinate structure. Na? Otherwise, its answer will be wrong. In that case, if you consider single, so might be your answer coming into the negative. So again, you can say the structure is unsafe. So that is not the right answer. So first of all, the way we studied, you can follow that only. That is a precise conceptual thing. Because if you go with the different methods, yes, for knowledge, it's always good. Fine. You should know different ways to solve a problem. But one standard thing that is understandable by making a free body diagram, that is a very good thing. So follow that. Try to make the free body diagram. Count the number of unknowns, count the number of members, then count the number of equilibrium equations. How many equilibrium equations do we have? As we have two members, total equilibrium equation will comes out to be 6 only, because for single member we have 3 degree of three equilibrium equations. Two for two, it will be 6 only. So 1, 2, 3, and one horizontal support reaction. 4 are the support reaction which is provided from their support only, and one is two from internal hinge. Total unknown comes out to be 6, and equilibrium equation is also 6. 6 minus 6 becomes 0. Either of the way you can adopt. Right? In the both way answer comes out to be the same. Let's see the next one. So this is a good question again, and you need to solve it. First try to solve them, and then I will explain it again. So guys, again, the problem which is mentioned on your screen is a good problem. It's need to be solved by the people. Those who are able to solve, that's a very good thing. Actually, they know the concept. It means this, if you are able to solve this problem, it means you understand the concept that we need to apply it to solve this problem. So basically, there is a frame which showing on your screen. One spot is fixed spot, other two are hinge spot here. So what we need to do in this problem, the degree of static indeterminacy NS we need to find, and the kinematic indeterminacy NK we need to find, which is frame which is showing into the your screen, and axial deformations to be negligible. In that case, we need to find that. So first of all, as asked into the question that we need to find static indeterminacy, for that there are two ways to solve. So first I'm going to one way which is going to explain first, then I will put you the second method that you can follow to solve. Fine. If you say there is a way to solve, first way to solve this problem is that we need to apply some cuts. Cut means there is a cut, we need to make this structure to be open structure. That should be like a tree kind of structure. As you see the tree, there is no branches are going to be interconnected there. They are different sections. So maybe we need to make it a open kind of structure like a tree structure. So we need to cut those. which are connected. If you see, these are the connected members. Fine. What we need to do, we need to apply cuts here. So we need to count the number of cuts, then multiply by the 3, as it's considered to be a rigid cut. So there will be three releases will be there for every cut. We need to count 3 releases will be there, because rigid body जब भी आप cut करते हो, there will be 3 releases of forces. 1, 2 are horizontal and vertical reaction, other is rotation for plane frame, and minus the R. R means the number of restraints you need to apply to make the structure completely rigid. Before applying the cuts, what you need to do that you have to
यही करेला ओकरा जैसे मेरा मीटर लगा है, जैसे हम बिजली बिल भर रहे हैं, वैसे उसमें डेट मेरा दिया हुआ
So what we need to do is there frame which is showing. First of all, to apply the cuts, we need to make the structure to be rigid. Rigid means whatever the other sports other than fixed sport we have, we need to make them rigid. We need to fix them. So before doing cut section, or we apply the cut section, we need to make these sport to be rigid. Rigid means how many additional sport reactions we require to make this sport to be fixed or rigid. So if this is a hinge, how many reactions I to require to put to make this sport to be rigid? 1. Similarly, for this case also, there is a hinge sport, and again we need to apply 1 extra additional sport reaction to make this sport to be rigid, or you can call it as fixed sport. Now, after making completely rigid this frame, you need to apply the cuts. Cut is required. Why? To make this structure to be open structure. Now you can see it's a connected members. These member is connected. If you apply a cut here and apply a cut, make their free body diagrams and count the number of reaction in that case. So there is a relation. Either you can choose this one, or you can count directly, cut them and count their number of reaction. That is the other way. Let me put it this first, and then I will go to that particular different way to solve this problem also. I will let you explain that one later on. So first make this rigid and apply the cuts. What you need to do, the second thing is after making rigid, how many cuts we need to apply? There are 2 cuts we need to apply to make this structure to be open. Then number of restrictions we require to count, how many restraints or we are need to apply to make this code to be rigid. So there are 2 restraints we require to make this structure to be rigid. 3C, 3 into 2, 6 minus 2. So there will be 4. Degree of static indeterminacy coming out to be 4. Right. So what are these? These are the 2 cuts we need to apply, as you can see in the diagram. So see, there are 2. C means cut is 2 reaction or restraints that we need to require to make my structure completely rigid is 2. NS will coming out, that is static indeterminacy 3 into 2. 3 into 2
Yes,
minus,
sir.
yes,
Your voice is not clear.
no. Is there any question?
Sir, your voice is not clear.
My voice is not clear. Hello? Now it's okay?
No, sir, it's not clear.
No, sir. Still same.
Sir, एक second यार.
So we are discussing about the cut section. So how many cuts we need to apply? We have to apply 2 cuts to make this structure to be open, 3 kind of structure. So there should not be any connected members. So first of all, make this structure to be completely rigid. So we require some restraint to make this structure. So there are 2 support reactions which are hinges itself. So one hinge is here and other is here. To make this these 4 to be fixed, first of all, we need to add 2 restraints here. So one for hinge support, other for second hinge. So total number of restraints we have to add in this structure to make this complete rigid, that is 2. Now we need to find NS, which is static indeterminacy, which comes out to be 3C, 3 into 2 cuts, that is coming out to be 6 minus the restraints that we required to make the structure rigid, that will be coming out, that is a 4. So this is the NS that we need to find, or you can say static indeterminacy. That is a one way to solve it. The second way to solve this problem, in that case we are not going to make these sport reaction to be rigid. Fine. We are just considering the same as it is the structure itself. So what you need to do, first of all, count the number of support reaction do we have. So 3 for fixed support, 2 for hinge support, 2 for this hinge support also. So how many support reaction do I have? 7. Fine. 3 plus 4, 7. Then you need to cut here and cut this section here also. So 3 will be released from this cut, 3 will be released from this cut. So both side be free body diagram. While you representing free body diagram, in that case you have to show both side, but counting them once only. So 3 plus 3, 6, and plus 7. So how many total degree, or sorry, reactions, support reactions, or an internal reactions do we have? Total is 13. Fine. Then count number of members after cut these frames. So one this section, one member this one after cutting this. Second is this T kind of structure, and third is again this one. So total 3 members are there. For particularly one member, how many equilibrium equations do we have in case of beam and frames? 3. 3 into 3, that will become 9. Total unknown was 13. 13 minus 9 again coming out to be 4. Either of the way you can adopt to solve this problem. One is for 3C minus R. For that you need to make first completely rigid structure, means you need to count how many restraints you add to make that structure to be rigid. Then you need to cut that and multiply by 3, because for one cut 3, why this 3 coming? For one cut, when the body is rigid, there is always, if it is in plane 2D, in that case there will be 3 reaction going to be released. That's why 3 is there. 3C minus R. R is the restraints that we need to require to make my structure to be rigid. So that is the different way to solve this problem, other the way that we always used to do by that kind of to solve that problem. Just count the number of reaction, cut and count the unknown reactions, forces which are going to be released after cut this section. So 3 plus 6 will be there. Total is 6 plus 7, 13, and then count the number of available equilibrium equation for each and every component of this structure. That for after cutting, this frame will be divided into 3 members. For one member we have 3 number of equilibrium equations. So 3 into 3, 9. That coming out to be 13 minus 9 again 4. Fine. So that is a static indeterminacy. How many kinematic indeterminacy do we have in this support system? So let me count them as well. So what is the way to solve this? There will be 6 kinematic indeterminacy will be coming out. That how? First of all, count the number of joints: 1, 2, 3, 4, 5, and 6. There are 6 number of joints we have in this structure. So the way we always follow to solve this problem, first do not consider these restrictions. Just count the number of degree of freedom without any restrictions. So 6 into 3, 18. One is the way that is the way to solve. Then count the number of reactions we have, means restriction is provided. There are 7. So total without inextensibility, if you are considering, assuming axial was considered later part, I will explain that as well. First, consider there is no restriction available in the frame. Count the joints, multiply those joints number into 3. In the case of beam and frames, total degree of freedom will come out to be 18. Then minus the support reaction, that will be coming out 18 minus 7. How many? 11. 11 minus, assuming axial deformation to be negligible. How many axial deformation will be minus in this case? How many members do I have? 5. Jitne member hai utne aap minus kar dojenge. So that's how you can get the value. That's it. So number of members count karo: 1, 2, 3, 4, 5. 5 members minus those 5. For one member, how many in axial deformation will be there? 1. So total 5 will be minus. Then we are remaining with 6 only. But are these 6? 1, 2, 3, 4, 3 and 4. अगर यहाँ count करोगे 5 and 6 only. These are the 6. Here 1, 2 rotational. Here 1 rotation, 2 rotation, 3 rotation, 1 axial. So these are the total 6 kinematic indeterminacy remaining in this. So I hope it is clear to all. Both the method I just explained.
Yes, sir.
Yes, sir.
So next is this is the problem which is showing on your screen. Try to solve this again, and students. So again, this problem is belonging with the truss system. So there is a very simple relation to find this static indeterminacy in this particular case, that is m plus r minus 2j. That's it. That we need to apply. If it is kinematic indeterminacy, do need to find, just count the number of joints, multiply by 2 and minus the number of reactions do we have. So let's count one by one. So if you see, if you want to calculate degree of static indeterminacy, we have the relation, that is m plus r minus 2j here. M is the number of members. The total number of members, how many members do we have? In 12 members. So count them, you will see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. In the truss system, every joint, every member is connected by the pin connection. So pin connection means every connection, these connections are there, they will consider to be a single member. So total number of members coming out to be 12. Sport reaction, there are 3 hinge sports. So at particular one hinge sport, how many sport reactions do I have? 2. So total is 3 into 2, that will be 6. Number of joints, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of joints are 9. Put into this relation m plus r. M is 12, r is 6, minus 2j. So 18 minus 18. Degree of static indeterminacy coming out to be 0. Fine. So that's how you can calculate.
Yes.
This structure or truss system is statically determinate. So if you want to calculate kinematic indeterminacy also, that we can also calculate by using just a very simple, again simple way to solve it. Just we have number of joints 9. If there is no restrictions, in that case, how many degree of freedom do I have? 9 into 2, that will be 18. Then count number of sport reactions. These are the sport reactions. There is restrictions in 2 directions. There is also restriction in x and y direction. There is also restriction in x, y. Means there are 6 sport reactions are there. So total will be 12. 12 will be the degree of kinematic in this case. अब उनको represent करोगे तो just count the joints where we need to show them. 1, 2, 3, 4, 5 and 6. These are the 6 joints. Each joint have 2 degree of kinematic indeterminacy and represent them. So that's how you can calculate the value of static and kinematic indeterminacy in the case of this planar kind of planar truss system. So there are the things this is there. So next is again a simple problem that you can see from there, that is you need to find kinematic indeterminacy of a single bay portal frame which is fixed at base. So how many degree kinematic indeterminacy do we have? There will be 3j r minus m. 3j r minus means 3 at particular joint that are the without any restrictions that we need to count. Then r is the sport reaction, m is the number of members. If there is inextensibility, we are going to consider. So number of members are 1, 2, 3 joints, 1, 2 and 3 and 4. Number of reactions, there are 2 fixed sports. At particularly one fixed sport, we have 3 number of reactions. So total will be 6. Put into the relation 3 into 4. These are the total degree of indeterminacy without considering sport reactions. Then minus the restrictions. Restriction is just provided by the sports only. 3 into 12 minus 6 minus inextensibility. So that you will get. If it is in this question, there is no mentioning that there is no inextensibility or extensibility. If it is not mentioning, either you can consider or not. That depend upon you. Otherwise, it's generally it's might there will be mentioned always in the question whether we need to consider inextensibility or extensibility. Fine. Shear or axial deformation is negligible or not. That will be mentioned if it is asked in the exam. So next is again very important question. We need to find, this is a fixed port, fixed beam. We need to find out the statical indeterminacy and degree of indeterminacy of this structure. So how many sport reactions do I have? In this case, we don't have journal loading. It's a transverse loading straightway which is given. You no need to go with the journal loading case. Then in the journal loading case, you have to consider the three equilibrium equations, so three spot reactions. So if it is a vertical reaction, in that case, you have to just go with the only vertical, because there is no horizontal component of this this force is coming. That's why we can nullify the spot reaction in horizontal direction. So in the case of transverse loading, if it is not mentioning, there is no journal loading, in that case, do not go with the spot reaction which is acting in horizontal direction. So make sure that question might be wrong if you consider horizontal reaction as well. But while solving that problem, you have to remove the one equilibrium equations also. Fine. You do not need to consider the equilibrium equation in the horizontal case. Fine. If you remove the reaction, you have to remove the vice versa. You need to remove the equilibrium equations also in the case of horizontal direction. So total number of equilibrium in this case 2, not consider 3. If there is a journal loading, in that case spot reaction also will be 3 and equilibrium equations also 3. But if it is there is a transverse loading, or you can call it as perpendicular to the longitudinal axis, in that case only you have to consider number of reactions to be 2 plus 2 4, and the number of equilibrium is also coming out to be 2 only. And our structure is indeterminate by how many degree of indeterminacy? By 2 degree of indeterminacy. So you might get confused by taking by solving this problem. It's a simple problem actually, but problem is that many people generally go with the 3 only. So directly they will put 4 minus 3, and they are with the answer of 1 only. So in that case, answer will be wrong. Make sure if there is a journal loading mentioned. Journal loading means the loading can be any angle. It can be at inclined 30 degree, 40 degree, 60 degree, whatever it is. So in that case, there will be two component of that force, either in vertical and in horizontal direction. In that case, we need to consider the spot reaction in horizontal direction as well. So in that case, total number of reaction will coming out 3 plus 3, 6, and number of equilibrium equations will be 6 minus 3. Answer will be 3 in that case. So it is transverse loading, like the problem mentioned in this. So you are considering 2 minus 4 minus 2, and the answer will be coming out to be 2 only. So I hope it is clear to all. So next
सर यहाँ पे
problem.
अगर सर
Yes.
सर बैक क्वेश्चन सर सर अगर सर वहाँ जनरल लोडिंग ना हो सर तो फिर
Now this is case is not non-journal case, right? It's a transverse loading case. Journal means can be at any angle, like inclined, can be at inclined or 80 degrees, 75, whatever it is. In journal, if it is mentioned, in that case you have to consider 3 spot reaction and 3 equilibrium equation. If it is this kind of problem, in that case you have to go with the 2 plus 2 and 2. Fine.
Okay, sir.
So next is we have to find out the degree of freedom of this problem. Again, it's a frame structure. We need to find degree of freedom or kinematic indeterminacy. Again, the same approach we need to do in this also. First of all, count the number of joints. How many joints do I have in this problem? I have 4 joints. So 4 into 3, that will be 12 minus the restrictions. You will get your answer. So degree of freedom, that will be coming out 3j minus r. J is the joint, 3 is the number of reactions which are going to be provided if there is no restrictions. So in a frame and beam, we have 3 number of spot reaction always there if it is beam and frame, minus number of restrictions. So total number of reaction, if you count, there are 2 hinges. For particular one hinge, how many spot reactions do I have? 2 and 2, 4. These are the spot reaction which is mentioned on the frame. Then number of joints 1, 2, and 3 and 4. There are 4 joints. Just put into the relation, that is 3 into 4 minus 4, coming out to be 8. What are these 8? Without considering extensibility, means there is no extensibility. In that case, I am getting degree of freedom is equal to 8. What are these? 1 and 2 here, those 2 rotational, and 3 here and 3 here. There are 6. 6 on this point, 3 at this point at joint number 2, and 3 on joint number 3, and 1 at 4 and 1 at 1. So there will be total there is decays coming out to be 8. These are the 8 components. Fine. If you consider inextensibility, how many degree of freedom will be reduced? In that case, for particular one member, one inextensibility will be negative. There are three members, just count minus the number of members. Fine. Number of members are three. For one member, one degree of freedom will be reduced if you consider inextensibility. Fine. Or you can call it axial deformation to be considered negligible. Inextensibility मतलब axial deformation. Shear का मतलब shear deformation मतलब axial horizontal direction you are not considering. So that's how we are going to calculate. So value will coming out to be 5 in that case. Minus the 8 minus 3, that will be 5 only. Clear? So 5 will be one rotation at here, one is here, other rotation here. How many? Total 3. One rotation is here, also 4, and one is x direction. There will be 5 only. Right? Last problem of this lecture, which is 10th number. We need to find out kinematic indeterminacy of plane frame, which is showing on the figure. I'm just going to show you. So this is the frame. Again, a very, very good question. Because in this case, I just introduced one internal pin. And internal pin, if it is there, it will give you one additional degree of freedom. So additional degree of freedom, but how many members is connected with the pin? Minus 1. That will be the additional degree of freedom which is provided by the internal pin. So that's how we can solve. Let's see of this problem. That we, first of all, let's see what is the concept of this particular hinge here. The joint hinge, if it is added, it always give you one additional degree of freedom. How we can calculate? M is the number of member which is connected with this hinge. If there are 3 member connected, in that case there will be 2 additional degree of freedom. If there are 4 member connected, in that case 4 minus 1, there will be 3 degree of additional degree of freedom will be there. Here if you see in this problem only, there are 2 members connected. One is this one, other is this beam, and one is column. So just put number of member connected 2 minus 1. There is a 1 additional degree of freedom will add here. Fine. Then the way we need to find that will be remain same. 3j minus r plus additional degree of freedom. Fine. If there is no, if there is any inextensibility, in that case that we can minus later on. First of all, consider directly by taking this one 3j minus r. 3j means joint. Count the joint 1, 2, 3, 4. Fine. For each and every joint, how many degree of freedom do we have? That we need to put 3 into 4. Each and every 3 joint will be 4 joint are there. 3 spot reaction will be there for each and every joint. 3 into 4, that will be coming out to be 12. Minus 4, how many spot reactions? 2 plus 2, 4 plus 1. Plus 1 by, because due to hinge is introduced, there is a 1 additional degree of freedom will coming out. How that additional degree of freedom we can calculate? By using this relation. How many members? First of all, we need to count how many members is connected with that hinge. M members. M stand for member. M is, there are 2 members. 2 minus 1. So there will be 1 additional degree of freedom coming out in this problem. Right? Then minus the inextensibility. Inextensibility means how many members do I have? 1, 2, 3 is there. Minus 3, and you will get 6 degree of kinematic indeterminacy in this. That's how you can get. So how many? What are these 3? 6. 1 rotation here, 2 rotation here, and 1 rotation here 3, and x direction 4, and 1 rotation on this beam, and other rotation in this beam. So total 6 will be there. So rotation on the both member is possible. So that's why I'm counting them twice. Okay. So ये ध्यान रखना है थोड़ा सा. So there are 6 number of degree of freedom if we consider inextensibility as well as hinge portion. So this question is very important. You need to be very careful while you are solving that kind of problem. So I hope so everybody gets some idea about how to solve that kind of problem. If anybody have further queries after sharing the notes, you can visit them. And if you are not able to understand how sir solved the problem, you can ask anytime. I am ready to solve those problems or your queries.